Good morning, ladies and gentlemen. Welcome to RSU SSH 2020 conference presentation. My name is Dr. Oon Cheen Sean. I am a lecturer at the School of Engineering, Monash University, Malaysia. Monash University, Malaysia is situated at Bandar Sangway. It is about 40-minute driving distance from the Kuala Lumpur city centre. Table of contents. First, I would like to discuss my research fields. My first research fields will be heat transfer and fluid mechanics. There I will discuss different working fluid I use to enhance heat transfer along with the geometry modification. There I contributed one conference paper to this conference. The title is Convective Heat Transfer and Application of Colloidal Suspension Fluid Flow in a Unique Geometry Flow Passage. My second research field will be fouling and fouling mitigation. There I will discuss how to mitigate fouling, what is the methodology I use, and what is the recent development of the fouling mitigation using carbon-based coating or additives. Then I would like to acknowledge the contribution of parties involved. Heat transfer and fluid mechanics. Present research investigates the impact of functionalized colloidal suspension on heat transfer. So I've conducted investigation on heat transfer and pressure drop characteristic in various heat exchanger geometry to obtain enhanced heat dissipation. This is one of my area which modify the geometry of the flow passage to target certain area and then enhance the rate of heat transfer in that area. I also perform experimental and numerical studies to evaluate the characteristics of different colloidal suspension. I developed heat transfer media for improving the turbulent convective heat transfer performance in a closed conduit. Moreover, I use ANSYS software to simulate heat transfer and hydrodynamic characteristics of colloidal suspension. Flow separation will help to induce more heat transfer due to the recirculation flow or recirculation zone. The unique geometry design in the annular conduit will help to enhance convective heat transfer with little effect on pressure loss. And then I also use functionalized carbon-based colloidal suspension for heat transfer enhancement. So as you can see in the figure below, the functionalized GNP or graphene nanoplatelets shows highest convective heat transfer among all the nanoparticles or nanofluids. Fouling and fouling mitigation. Fouling can be defined as undesired deposition of sedimentation on heat transfer surfaces. Roughly about 1 to 5% of energy consumed by the industrial sector is used to overcome fouling. Our main goal is to maintain the efficiency and prolong the lifetime of the heat exchanger. Graphene was widely used for membrane and defouling research. However, limited research was conducted on anti-fouling of heat exchanger using carbon-based material. So my research is to develop an innovative bio-based covalently functionalized carbon-based additives and coatings. And the preliminary result shows very promising mineral fouling mitigation using the functionalized carbon-based additive, and by reducing the fouling, we are able to reduce the carbon footprint, create economic benefits, and also protect the environment. Functionalized graphene exhibit high thermoconductivity and water repellent characteristics. Graphene nanopellets will be functionalized with the bio-based extract such as clove bark, phenolic acid, and empty fruit bunch. This is because the material produced is non-toxic and will not pollute the environment. On graphene coating using physical vapor deposition method, and we are exploring 3D printing method to coat graphene composite onto the surface of the heat exchanger. The result shows the fouling effect reduces. Acknowledgement. I would like to thank Professor Kanda for her hospitality and invitation as an invited speaker to this conference, and she is the director of Research Institute of Rancid University and also the program chair of this conference. I would like to thank also RSU SSH 2020 conference organizing committees for organizing such a big conference during this difficult time. And last but not least, I would like to thank Monash University Malaysia for the support provided. If you're interested in my research or you have any questions, please drop me an email. I'm happy to receive your email, and I hope to see you during the conference online. Thank you.